Hi everyone. So today I'm going to be going over literal equations. It's Coach Fred, and I'm going to be doing the really spicy on fire version when we have to solve a literal equation by reverse distribution. I know, what the heck, Coach Fred? It's really known as factoring out a GCF. So here's what I mean. I give you, if I gave you something like this, 2L plus W with parentheses, I know that what you would do is you would distribute the 2, and you'd be left with 2L plus 2W. However, now we actually have to get from the simplest form and get it into what we're going to call factored form or GCF factored form. We're taking out the GCF. So we look at both expressions and we're like, what's the common factor that they have? So in this case, they both have a common factor of a 3. That's the greatest common factor. So we pull it out to the front. If we pull that out, think backwards distributive property. It's the distributive property in reverse. That would leave me with A minus B. How do I know I'm right? Well, if I distribute it back in, I should be left with that. All right, a greatest common factor can also be a variable. So in this case, in this next one, a little bit harder, I can see they both have a factor of 2L. All right, so that's my greatest common factor. So I pull it out to the front. I'm going to use a cursive L. I'd be left with a W, but I pulled out a 2L of a 2L, so I'd have to add a 1. Whatever's in the parentheses has to have the same number of terms as my original. All right, a GCF can always just be a variable as well. So looking at this next one, I can see it has a greatest common factor of an F. They both have an F, a factor of an F. So F gets pulled out to the front, leaving me with B plus A. Now remember, leaving me with B plus A. Leaving me with B plus A. All right, last one. Math teachers love to throw you off. This one, you might notice, it has a 2. It has a pi in both. It also has one factor of an r in both. R squared and r both have one r in them. So our greatest common factor would be 2 pi r. All right, if I took a 2 pi r out of the front, I'd be left with h. And if I took a 2 pi and one of the r's, I have 2 of them here, away, I'd be left with plus r. Now remember, if you're ever unsure, just redistribute to make sure you've done it right. If I distribute, that means multiply. I'd have 2 pi r times h, and then I have 2 pi r times r to the 1 times r to the 1, power times a power, add them high, I would get r squared. Okay. The reason I wanted to show you that is because we have to use that sometimes when we're solving literal equation. And again, these are the ones that are on fire. So I'm going to model it. This question says, solve for C in terms of A and B. That means that you want to just get it to C equals. Okay? C equals is my goal. So I have to notice on the left that they both have a factor of a C. So I'm going to pull that out to the front, and I'm going to be left with A plus B equals AB. Now, remember, the goal was to get C equals, so I have to get C alone, so I'm trying to isolate C, and C is being multiplied to A plus B, so now I can divide both sides by A plus B. So C is equal to AB all over A plus B. All right, let's try one. If A plus AR equals B plus R, find the value of A in terms of B and R. That means I'm going to have A equal with an expression with BR in it can be expressed as. So I have to notice that A has an addition sign in, and it's an expression with addition and subtraction. So this is where I'm going to have to reverse distribute or factor out a GCF. So let me rewrite this for myself. I'm going to factor out an A. Remember, I have to have the same number of terms I started with. So A times what would give me A would be 1 plus R equals B plus R. All right, I'm solving for A. So I'm going to divide both sides by 1 plus r. Now, because the right side has a plus in it, I want you to be really careful. You cannot simplify these r's because the expressions in the top and the bottom both have an addition or subtraction symbol. So that's a in terms of b plus r. All right, that was hard, wasn't it? You try. If k equals am plus 3mx, the value of m in terms of a, k, and x can be expressed as. Okay, so the value of m in terms of, that means m equals. That's your hint. Okay, you try. All right, so you factored out hopefully an m on the right side of the equation, leaving you with a plus 3x, and then noticing you were trying to get m alone, divided both sides by a plus 3x. So your answer would be k over a plus 3x equals m. All right, hopefully those were some helpful videos. Remember, there's part 1, part 2, and part 3. If you want to try one on your own, I will leave one in the comments.